And I will use, I'm going to turn my video off. You don't have to turn yours off, but I'm going to turn mine off so I can work my document cam. So, because I like to use the document cam to get things started, and also sometimes I write definitions in my own words, so it's easier for some of y'all to understand what the actual definition is. So sometimes it lags. So if it lags, it's not a big deal, just a little behind. Let me do one more thing. Well, there we go. There. All right. First thing is capital S statistics. Now, the reason I'm saying capital S is because I don't know what the word is in English that describes two words that have, or one word that has two different meanings. Y'all fill me in on that if y'all remember that from English. But statistics with a capital S is the science of collecting, arranging, calculating, and interpreting. And I try to spell interpreting right, data. Okay, that is the definition of statistics. The science of collecting, arranging, calculating, and interpreting, if I spelled that right, some of you spellers, make sure I spelled that right, and interpreting data. That's capital S, statistics. So I take my handy dandy yellow highlighter and I'm just going to highlight that S, because that's capital. Now, there's two things in statistics that we start the class off with, and that's two definitions: population, and sample. Population is the big guy, okay? And sample is the little guy. Sample is a subgroup of the population. That's pretty self-explanatory. It's always the smaller group. Now, with population, you have to use formulas, okay? And the variables that we use in the formulas are called parameters. Okay, population, when you do a mathematical calculation in population numbers, you use parameters. That's what the variables used are called. And parameters are usually in population calculations Greek letters. They're usually Greek letters. And those Greek letters, a couple of examples are mu and sigma. Mu looks like a M with a long tail on it. And sigma, lowercase sigma, is a O with a pompadour on top. Now, a sample uses variables used when we do a calculation in a sample is called a lowercase statistic. And that's where you see the definition for lowercase statistic. And those are usually alphabetic, meaning the letters we use in alphabet. And two examples are X bar and S. Now, this is important because in order to understand statistics, uppercase statistics, you've got to realize where the data is coming from. And the data is coming usually from the sample to predict the population. Now, does anybody have any idea why we take the sample to predict the population? Does anybody have any idea?
It's too difficult to ask an entire population something.
Yes, because of two important things. And what are those two important things that's important to everybody and every corporation? I'm not asking you to think about corporations or what's important to you. What's important to you is important to everybody, and it's important to corporations. Anybody want to take a guess? Ms. Poor, you need to move over a little bit to the left, and your head would be right in the middle of your initials. There you go. Time and what?
Money.
Time and money. Now, a lot of people say, well, money is not important to me. I'll BS. Bull crap. You want to pay your freaking bills, don't you? Okay? You got to pay your bills. I mean, you can't have stuff if you don't pay for it. And if you want to live in a cardboard box in a ditch, then I guess money don't mean anything to you. But I don't think you're going to be in a Math 120 course and want to live in a cardboard box in a ditch. So time and money is important to everyone and every corporation. So as Mr. King said with his interaction, about the only interaction I'm going to get today, the sample is used to predict the population. So a good example, if I want to find out how many people drive cars versus SUVs and trucks at Tri-County Tech, I'm not going to go out and count every single truck and every single parking lot that Tri-County Tech owns, including the Anderson campus, the Pendleton campus, the Sandy Springs campus, the Oconee campus, and the Easley campus. I'm not going to do it because that would take too much time, and time in the business world means money. So what I will do is I will go to the Anderson campus or the Pendleton campus, not the Pendleton campus because it's too big. I would go to the Anderson campus, the Easley campus, or the Oconee campus, and I would use that, one of those, as a sample. And that's where we get that saving time and money. So that is what the first part, the first couple of pages of your book is going to try to get into your brain right here. So also, there's two kinds of tests. There's unit tests and there's standardized tests. I usually tell you what's on both. And I'm going to tell you right now, all of this material right here is going to be on both my unit test and any standardized test you take whether it is an SAT, an ACT, or a GRE, or a TEAS test, it's going to be on there. What is statistics? Capital. What is population? What is a sample? And parameters go with population. Remember the P's. And sample goes with statistic, lowercase. Okay, so let's go move on. Let's see, where is my handy dandy? There we go. And you're going to see that there is the population in the sample. Now, the only thing lower than a sample is a individual, and I'm not going to explain to you what an individual is. I'm really sure y'all know what an individual is. All right, write these down because, well, I'm going to tell you what the definition is, and then you can look at the wordy definition. I better make sure I spell it right, isn't it? D-E, yeah. Descriptive statistics means basically statistics that you, underline you, sorry, statistics that you collect and calculate. And your result is usually just a result. In other words, if I go out and I look at all your grades for your Unit 1 test, and I go out and I pull all your grades and I find an average, then that's pretty much descriptive statistics. Like the average grade, an average grade for either my class, or you could find your average by taking all your unit tests and dividing by 4. Okay, usually a good example of descriptive statistics is finding an average grade. Where inferential, and that is right there, because I usually try to put two F's or 2 R's in it, so I have to make sure. Inferential, and I hope I spelled it right, infer, and then E-N-T-I, yeah. Inferential statistics is statistics from another source, sorry, from another source, and you use it to predict. And the key word is to predict.
You have a work email.
Now, that's pretty layman's terms, but I'm going to give you an example. You go and you write this down. You go to the highway department. Example. You go to the highway department and you pull drunk driving deaths last 5 years. In other words, how many deaths on the road were by drunk drivers, were committed by drunk drivers? In other words, drunk driver runs into somebody, somebody dies. The drunk driver doesn't, okay? And you want to predict the drunk driving deaths in 2021. That is an example of inferential statistics. Did you go out and count how many people died of drunk driving incidents? No. You used the highway department's information, and you are going to predict the driving deaths for 2021. That's inferential. Okay. Now go back to the handy dandy definition, wordy definition. Consists of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. A statistic is a numerical summary based on a sample. Now, I'm not a rocket scientist, but I think my definition makes a whole lot more sense than that. But some of y'all may be wordy people. I'm not a wordy teacher, so I try to cut to the chase. All right? And I do like one thing. It's you're summarizing data versus predicting. Okay? So descriptive, you summarize. You summarize data, where in inferential, you predict. I guess that's a good way to memorize or remember it. And there's your lowercase statistic with the sample and parameter with the population, which I showed you before. Okay, everybody feel good? Yeah, Hubert, everything's good. I understand. Thank you. Glad. Always good when a class interacts with their teacher and not be weaned on a pickle. And that gets no response whatsoever. Y'all just hate me? Is that what it is? No, we don't hate you, Hubert.
No, we don't.
What?
I said we do not hate you.
Okay, thank you. You just want to make me feel uncomfortable by not talking to me. Miss Gravina, where are you? Can she hear me?
Yeah, I can hear you. Can you hear me?
Hello, Mr. or Miss King. Yeah, I can hear you.
I'm at Tri-County.
You at track which one?
The Anderson campus.
Oh my. Okay, where are you sitting so I know where you at?
I'm upstairs, like where the 200 wing is.
Okay, so you're in the lobby?
Yeah.
Okay. All right. Well, I appreciate you calling in from the Anderson campus.
You're welcome.
Okay. Who was that, Miss King, Mr. King, that stuck their head in the picture?
That's my mom.
Oh, okay. I thought it was your sister. Or sorry, your girlfriend. I didn't know. I couldn't see. I couldn't see but a portion of her head, okay? Now, before any of you take offense to that, because, you know, we are in buttercups and snowflakes, I only saw part of a face, okay?
I think she took it as a compliment. That's okay.
Okay, well, good. I'm glad. I'm glad because nowadays everybody's offended. All right. Variables. I'm not going to tell you what a variable is because I think most of you have been through enough math courses to know that a variable is a letter in a mathematical sentence. Okay? And that's basically what it is. Characteristics of the individuals within a population. Yes, you can use it as a variable, meaning something descriptive, like there's many variables in this, you know, that there's many variables why a student would fail this class. The variables are they have a job, they have too much of a social life, they sleep too much, they're lazy. You know, those are the variables. Or they got in a fight and somebody broke their leg and they weren't able to finish the course. Or something, you know, all kinds of stuff. It's variables. So variables, as well as a mathematical letter, it can also be something external on what you're looking at. Why did the person lose the election? The person lost the election blank. Why did the person fail the course? Because blah, blah, blah. There's 4 or 5 things. So for this case, you could say variables has two meanings. One, it could be a letter in a formula, or 2, it could be an external something, okay, event. And that's what basically a variable could be. Okay, here we go. Two test questions right here. And descriptive and inferential are test questions. All right, let's go here. What is qualitative data? Qualitative data versus quantitative. How many of you have heard the slogan, quality, not what? It's your parents' fault.
Quantity.
Good. Somebody heard it. Quality, not quantity. Quality, not quantity. Now, quality means category, meaning characteristic. Blondes, brunettes, and redheads. Blondes, brunettes, and redheads. Blue eyes, green eyes, brown eyes. Now, of course, we all know that brunettes and people with brown eyes, they're the exception. They're the top of the chain. Okay, we all know that, right? So anyway, those are characteristics. Let me ask you a question. Let's see if you're thinking. What is a zip code? Is a zip code qualitative or is it quantitative? It is qualitative. A zip code has no mathematical meaning. So I want you to put in red. So I'm going to get my red marker out. So that means it's telling you this is important. I want you to put a word math with qualitative, and I want you to put a big X through it. Because qualitative data means data that has no mathematical meaning. Somebody give me the average of blondes, brunettes, and redheads. When you do the average of blondes, brunettes, and redheads, you can't get an average, all right? The average of blondes, brunettes, and redheads is redheads. That don't make any sense, all right? What about area codes? Area codes are qualitative. And social security numbers are qualitative. What about your T numbers? T numbers are qualitative. Now, I'm mentioning these words or these different numbers because on a test, you will be given one of these. And they will ask you, what is this? You know, is it qualitative or is it quantitative? That will get you on a test because you think because it's numbers, it is quantitative. It's got to have a mathematical meaning. It's got to have a mathematical weight to it. 29626 as a zip code means nothing as far as mathematical meaning. So what is quantitative? Well, instead of categories, quantitative is usually in classes, like weight classes. Or you could say age, shoe size, give me something else. Age, shoe size, of course, I already said weight. What else? I can't think of anything right off the top of my head. Okay. I appreciate y'all interacting.
I
Thank
said
you.
height.
Oh, okay. Height. Thank you. So qualitative versus quantitative. Test grades. And so on. All you got to ask yourself is this. Does the average mean anything? Average age. Yes, that means something. Average shoe size. Average height. Average test grade. What is the average of the class? What is your average? All of those make sense. Average of blondes, brunettes, and redheads makes no sense. Now, let's show you the wordy definition, and you can write down what you want. Is this an SAT question, ACT question, unit question? Oh, hell to the yeah. The next two with these two are always going to be a standardized test question, SAT question, my test question, and that is discrete and continuous. I want everybody to get your calculator out. Get your phone calculator or get your regular calculator, whatever. Get it out right now. I don't care if you have to get your Sally Homemaker calculator. You know, the one that's in the pot holder drawer that looks like about this size, about, you know, you take to the grocery store. All right. I want you to do the following calculations in your calculator. Now, the first two or three are going to be very simple. The second two or three are going to be not so simple, so that's why I want you to get your calculator. Now, I'm going to use my calculator because sometimes y'all set me up and y'all tell me the wrong answers because you can't use your calculator correctly. So I'm going to pull up my calculator, and we're going to make sure y'all don't set me up. I don't know why y'all do that. I got 3 days left. I'm gonna need to hurry up and buy my calculator thing on here so I can. There we go. All right, clear. And I'm going to take. I want you to do. Let me pull up. I'm trying to get everything on here. Y'all work with me here. There we go. We're going to do 42 divided by 2. Well, we all know that's 21. I'm going to put 21.0. And then I want you to do 3 divided by 2. Well, that's 1.5. And then I want you to do 1 divided by 6. Now, I want each one of you to look at those 3 numbers, and I want you to tell me what the next digit is. What's the next digit right here? Right there where that line is, that blank. What is that digit? It's real easy. It's so easy that you might make it complicated.
0.
0. What's the next digit here?
0.
0. And what's the next digit here?
0.
No, it's not 0.
7.
Well, it's 6. Okay. But if you was to round it, it would be 0.167. But what is the 6 doing? It's repeating. So you can predict what's happening on that next digit. You can also locate these numbers on a number line. And you can count these numbers. Okay? All of those describe discrete. And I want you to write outside discrete, concrete. Concrete has a double meaning also. Concrete means solid, means that you can bet money on it. Can you predict the next number on all these numbers? Yes. If you can predict the next number, then it is discrete. Well, what is continuous? Well, if you can. Okay, somebody needs to turn their stuff down. Did we pick up somebody? Looks like we picked up Miss Anderson, didn't we? Did we pick up? We picked up somebody. Who came in late? Okay, nobody's going to own up to it. That's all right. I'll check the roll in just a minute. All right, continuous means what? Means that it's not concrete. It's not solid. So I'm going to put concrete, and I'm going to put an X through it. I want you, and I'm going to do it behind you, I want you in your calculator to take the square root of 2, the square root of 7, and go ahead and approximate pi. So I'm going to do that with you. 2 to the 0.5 power is 1.4142 135.62. 7 to the 0.5 power, 2.645751311. And second, caret symbol, 3.141592654. Now, I want each of you to put your calculators away now. And by looking at these numbers right here, by looking at these numbers, tell me the next digit. Oh, there's Miss Johnson. Hey, Miss Johnson. What is the next digit on this first one? COVID. Oh my God, I got COVID. What is the next digit? Come on, speak up. Thank you, Miss Owens. See, I told you Miss Owens would be here. Miss Owens is a winner. Aren't you, Miss Owens? All right. So nobody said anything. Is that because you don't want to interact with me or because you have no earthly idea? I have no earthly idea, Hubert. That's right, class, you don't. Why do you not have any earthly idea? Because there's no what? There's no pattern. Look at those numbers. Look at these numbers. Do you see a pattern? Everybody should say no. Okay, but there's always that one student that thinks they're John Nash and thinks they can see patterns and everything. All right. Do you see a pattern here? No. Do you see a pattern here? No. So with a continuous number, you cannot what? Predict that next digit. You cannot locate these on a number line because they're bouncing all over the place. And you do not count continuous numbers. You measure continuous numbers. What do we measure in the real world? What do we measure in the real world?
Length.
Meters, liters, and grams. And yes, length, distance, height. Yes. What is liters? Liters is volume, Hubert. That's right, class. You went through K through 12 and you learned that. What is grams? That's weight, Hubert. Thank you, class. So length or distance or height, volume or what? Weight. What is the height of a tree? That's distance. So height of a tree is continuous. That is a question on my test that half of you will miss. So you might want to write that down. Okay. Height of a tree is continuous. What about the number of cars outside your house? Oh me, y'all know what? Y'all are all gonna end up in a closet office at the end of the hall, and nobody's gonna talk to you in your career, okay? Y'all have got to interact with people. All right? You're gonna be sad. What is the number of cars outside your house? Do you measure that or do you count it? Okay, Miss Johnson just mouthed count. I can read lips. All right. So, yes, that means that the number of cars outside your house is discrete. Now, you would be surprised on how many people go through probability and statistics and can't tell you the difference between discrete and continuous. Now you can. Right? Yes, Hubert, we can tell now. Thank you for the interaction. Number of children. I would hope you count the number of children, so that would be what? Discrete. Household income. Continuous. Daily intake, continuous. Let me give you an example of why weight is continuous. How many of you, I'm going to talk to the females right now. How many of you have a scale in your bathroom? I do. And that scale is correct. But the doctor's scales is not correct. Correct? How many women? Am I right or wrong? You're right. Yeah. The doctor's scales is always incorrect. Some of y'all know what I'm talking about. Some of y'all never go to the doctor, so I don't know if you know what I'm talking about or not. Because weight and volume and height is subjective to the person that's actually measuring it or the device that is measuring it. That's why your bathroom scale is correct and your doctor's scales is incorrect. Why is the doctor's scale incorrect, ladies? Why is the scale that the doctor always incorrect? Because it always says more, Hubert. That's right, class. Thank you. Always nice to have a class that interacts. Makes the class go by a whole lot faster because we ain't even at 9 o'clock yet. Y'all still got another 30 minutes. Y'all gonna make it drag out to be 45 minutes because you don't talk. That's why you're gonna end up in a dadgum closet office. Nobody's gonna talk to you. All right. Go ahead and write down. Well, I'm gonna go to the book here because the book does a better than the slide. So I'm gonna go to the book, and if I could find the book, and we're gonna go to the book. I can't find everything at one time, so y'all just gonna have to bear with me. Let me go ahead and tell Miss, let's see, I'll do that later. There we go. And ebook, chapter contents, 1.1 ebook. And I want to go to the different types of data, and I want you to write them down out of the book. Now, you know y'all have a book. Y'all can actually follow along in the book. Y'all know that, don't you? Yeah, Hubert, we know that. Oh my gosh. Did I actually hear somebody laugh? No, that was my hearing, right? If somebody's following along, you're welcome to tell me what page. Okay, here we are. Okay, write those 4 dark words down, okay? Because I'm not going to tell you to write down the wordy definitions. Nominal level, ordinal level, interval level, and ratio. Poor old ratio. Now, nominal, ordinal, interval, and ratio. The easiest one to remember is ordinal, because in ordinal, you have to have your data or your measurements. There has to be some type of order. And I'm just going to tell you right now, a race. An example of ordinal measurement would be a race, because what do you count? First, second, and third. That's ordinal measurement. Ordinal measurement has to do with order. So make sure that's the easiest one to remember. Nominal is the second easiest to remember because nominal is a big umbrella. Pretty much everything is nominal. Everything. What about a race? A race is nominal and ordinal because nominal covers everything. Okay. Interval, a value of 0 does not mean the absence of quantity. So, what about being born? What about being born? If you're 0 days old, does that mean that you don't exist? Exactly. So you could say that age is, oh, I done got ahead of myself. You can say that age is interval. Because 0 days old does not mean that you don't exist. And ratio, poor old ratio. That comes from Andy Griffith. And if you looked at my sheet, you know that I love Andy Griffith. Temperature is a good example of interval. What does 0 degrees mean? That means it's cold. No, it means that is 0 degrees temperature. 0 does mean something with 0 degrees. And if you can't decide on a test, the best thing to do is put nominal, because nominal, it covers everything. Number of days during the past week that a college student studied. Okay, number of days, that would be ratio. Oral ratio. Letter grade. Letter grade would be ordinal, because it's ranked. Okay? So those are 4 good examples right there. So make sure you write those examples down. Mr. King, we got a change of scenery there. You had to move.
Yeah, my family was being loud.
Oh, I tell you what, you just can't. You can't pick your family, you know? You just can't. You know, they start drinking early in the morning like that and get loud. You just can't do anything with them. Oh, well, let me drink some of my vodka right now. All right, that's 1.1. See? Now, was that hard? Let's look. Let's look and see what 1.1 consists of. It consists of a definition of statistics, population and sample, parameter, and statistic. It consists of descriptive and inferential. That's the different 2 types of statistics that we actually do. One summarizes, the other one predicts. Qualitative versus quantitative. Qualitative versus quantitative. And discrete versus continuous. Now, Hubert, you didn't put the last thing. Well, that's more of a standardized test question. I really don't test you on the different types of measurements, the ordinal and all that. If I do, it's pretty straightforward. Like a horse race. A horse race would be ordinal. All right, let's look, see what's next. What's next in 1.2? Well, let me go to the slides, because the slides really do a better job at outlining. What's the difference between an observational study and an experiment? An observational study you're just basically perving. In other words, you're just sitting there watching. You're watching something happen. All right? I like to tell students, think of sleep apnea. I don't know how to spell apnea. Sleep apnea, I don't know if that's right or not. I'll just put it in quotation marks. That way it'll be, don't matter. Sleep apnea. What is sleep apnea? That is when people can't go to sleep, Hubert. That's right, class. And I don't know if I could find any videos on sleep apnea, but they do exist. But let me see if I can find one. And the reason I'm showing you this is so you can complain to my department head that I'm pulling up videos in class. Everybody else can do it, but if a math teacher does it, they get in trouble. All right, sleep apnea. Sleep apnea. I know I'm not spelling it right. Oh, I did spell it right. Did I spell it right? Oh, I didn't put a M in there. And let's see if they have any videos. They usually have videos where people put a night vision camera and watch people, okay, sleep. And I don't see any. I don't think I'm looking it up right. I don't think that's the way it's spelled.
That's it. It's APNEA.
So I did spell it right.
No,
No,
you
EA.
didn't. It's the top video.
The I, okay, E, okay. So sleep apnea, EA. Is that right? Oh, AP. Is that it?
Yes, sir.
Is it 2 words or 1 word?
It's 2.
Okay. Well, anyway, I have seen, and they don't have it on here, but usually it's in a night vision setting where everything's green and black, and they watch people sleep. And they probably have them here, but I'm not going to pull them up. But anyway, that is an observational study. Now, what if, okay, you listen, what if I was to take a cattle prod and every time somebody snored while they were sleeping, I stuck a cattle prod in their side and electrocuted them? That would be an experiment. Why? Why would me electrocuting somebody while they're sleeping, why would that be an experiment versus an observation?
Because you're interacting with them.
There you go. Good job. And she's interacting with the class. Experimental is when you have something to do with the project. You interject. You put yourself into the project some way, somehow. A rat in a maze. If you're observing it, you're observing. It's observational. If you put a block of cheese in the maze, then it's an experiment. All right? So experiment is when you actually interject, all right, or interact, or put something into it, all right? Basically, observational study is just watching. So observational is watching. Experimental is when you interact, interject, or put something into the observation. Now, is this a Hubert test question? No. Is it a standardized test question? Yes. So you need to make sure you understand the difference between the two. I know y'all getting double your money's worth. I tell you what's on my test and I tell you what's on standardized test. I know, I'm awesome. All right, next. We're going to pass all this because that just takes up time in class. Okay, let's talk about a response variable. In research, we wish to determine how varying the amount of a explanatory variable affects the value of a response variable. Now, right quick, I want you to change explanatory to the x-axis. All right, so we're going to write this down. Explanatory and response. Let me ask you a question. An ice machine. What goes into an ice machine or an ice maker?
Water.
Water. So the input on an ice machine is water. What comes out of an ice machine? Ice. So this is your x-axis, and this is your y-axis. Now, from your math classes in the past, what other words go with x-axis and y-axis? Think of your other math classes in the past. I'm looking for a couple of words. Just x-axis, I've already got input and output.
Cause and effect.
Well, that's a good, yeah, you could do that. Yeah, cause, I didn't think about that. But now that don't mean you can teach the class, Mr. King. Cause and effect. I drink too much wine, I have 2P. That's a quote from Matrix 2, the second Matrix movie. You know, the French restaurant, the key maker. Okay, forget it. Some of y'all don't even watch movies anymore. Y'all watch cartoons that are called movies. And right now, why do the movies suck? Oh, I know. Because Hollywood don't want to get out and catch COVID. All right. And they don't want to make movies. The movies right now suck. Have y'all watched a movie lately? They suck. Oh my gosh. Wonder Woman 1984. That movie was the dumbest movie I think I've ever seen. Have y'all seen that movie? Anybody? I wouldn't even tell you to go on HBO Plus to watch it. I didn't even make it through 3/4 of the movie. Nobody's going to even talk about it. I cannot believe that nobody in this room, in this virtual room, didn't go see or didn't watch, or they don't want to admit it. That's it. But name a movie right now that's decent. There is none. There aren't any. Okay, forget it. Nobody's going to talk to me, so I might as well just quit this job. I don't even know why I do it. All right, so x-axis and y-axis. Can somebody tell me what is a word from your algebra classes that you've had in the past that coincides with x-axis or y-axis? One of them starts with a D and the other one starts with an I.
Dependent and independent.
Good job. Dependent and independent. And one more. One starts with a D and the other one starts with an R.
Domain and range.
Good job. I tell y'all what, y'all are awesome. Now, when somebody tells you about an explanatory response and a responsive whatever, okay? Whenever they talk to you about that, now you can associate it with what? The x-axis and the what? The y-axis. And I guarantee you, nobody's ever done that with you before on explanatory variable and response variable. So hopefully you can put those two together. Do I test you on this? You might see a few homework questions, but I don't know if I test you, but I know they'll be on the standardized test. Anybody got a question on those two? Go ahead and write down confounding and lurking. What a word, lurking. Like Michael Myers on Halloween. Lurking. Do you know that Halloween was supposed to be named The Shadow? Doesn't work.
You mean the movie?
Yeah, the movie. Because it was supposed to be, he was supposed to be like a silhouette through the whole movie, and it didn't work out that way. I'm a movie nut. I love movies that are worth watching. That's why I couldn't make it through 3/4 of Wonder Woman 84.
What's your favorite movie?
Oh gosh. Now my favorite movie of all time is Gone with the Wind. But I love Rocky. I love the Rocky movies, except for Rocky 5. Rocky 5 should have never been made. I don't know. I love anything with Sandra Bullock in it, except for she made one or two movies that were stupid. That last movie she made with her being a political advisor, that was a stupid movie. But anything with Sandra Bullock in it. I love Hope Floats. That's one of my favorite Sandra Bullock movies. I don't know. I love them. I love a lot of movies. A lot. I'll have to think of some more, but anything Rocky and anything with Sandra Bullock in it and Gone with the Wind, those are some of my favorites. Now I do not like Sandra Bullock movie. I don't like the Miss Congeniality or whatever too, with that other woman in it. That woman that I don't even know who she is, but she's terrible. Is it Miss Congeniality? There was Miss Congeniality?
Yes, sir.
Which was, yeah. And then the second one had another woman. I don't even know who she is. She sucked. I mean, she was terrible. But I don't like that movie. I like Miss Congeniality, but I don't like the other one. I'm showing too much of my feminine side. I shouldn't do that, so I'll be quiet. All right. So, confounding in a study occurs when the effects of two or more are not separated. Therefore, any relation that may exist, variable, may be due to some other variable not accounted for in the study. Now, that makes absolutely no sense. Confounding is when something doesn't have anything to do with the other. Let me give you an example. Speaking of movies, let's say that I work at Amstar 14 and I also go to Tri-County Tech, and my project is to bring something from home and see if it's correlation, whatever. And this is the attendance for a Nicolas Cage movie. If you don't know Nicolas Cage, he's one of those eccentric actors that really is not a good actor, but all of his family is in Hollywood. Did you know that Nicolas Cage and Adrian on Rocky are cousins? And they are all out of the Corsigi family. You know, the director, Corsigi, or whatever his name is. That's how they get parts. They're nephews and nieces of a lot of directors. All right, there is the attendance for Nicolas Cage movies. And it looks like this. Everybody with me? In other words, when it started, nobody came, and by the time it finished, there were a lot of people watching it. And this, let's say Con Air. Con Air was a good movie because it had a lot of good actors in it. Like, what's his name that played Cyrus the Virus? Oh, I love him. I can't remember his name right now, but he plays villains all the time. What is his name? Somebody look it up. Cyrus the Virus. That's a good, I love him. I think his last name is Malkovich or Malkovich. And it had the guy with the crooked teeth and the weird eyes. He's a great actor too. But anyway, I'll shut up.
Is it the actor with like the bleached blonde hair and blue eyes?
No, I know who you're talking about. He played on Walking Tall. Yeah, he plays a good villain too. I don't know who he is, but I'll have to pull up Cyrus the Virus before class so everybody can see it.
Is it Don Callis?
It may, no, that don't. Did you look up Cyrus the Virus?
Yes, sir, I did.
Well, that's not it.
Oh,
Is it
Con
John-
Air.
John
John Malkovich?
That's it. And look up the cast, and there's a guy with the crooked teeth. He's got an Italian name, last name, and he played on a lot of movies. He played on 28 Days with Sandra Bullock. He was her counselor when Sandra Bullock was in the whatever, recovery or whatever. Anyway, and this is the suicide rates in Anderson for that same week or same month or however long a movie. So does this mean that Nicolas Cage movies make you commit suicide?
Yes.
No.
No. It's supposed to be no. But if you watch Wonder Woman, if you make it through Wonder Woman 84, you might want to drink, okay? This is confounding. Meaning that it really doesn't have anything to do with each other.
Gmail.
Versus a lurking. And we'll stop with lurking, but let me ask you this. What if you have drowning deaths and Rocky Mountain spotted fever cases? Does these two have anything to do with each other? Yes, they do. You get most of these in the hot weather months. This is a lurking variable. Does everybody see that? Do you get Rocky Mountain spotted fever in December? Do you drown in December? No. Nobody's smart enough to get in a lake in December. Now, I'm not even going to talk about the Polar Bear Club. We're not going to talk about them. All right? So, a lurking variable is something that combines two other variables. So, lurking does relate. Confounding does not relate. All right, so we're going to stop on lurking because I don't want y'all to go through, convulsions. Let's see, it's about 9:18. I think we get out at 9:25, but we got a minute. Let's have a little bit of fun and go pull up those two actors because I can't remember their names and let you see who they are. Let's see, what do we do? Con Air cast. Yeah, there's John Malkovich. There he is. I don't know how to say his last name. Steve Buscemi. You got all kind of good actors there. I don't know who that is, but Vin Rames, he does the commercials. He does the voiceovers for Arby's. And Danny Trejo, everything Danny Trejo in, I like Danny Trejo. Star Trek, The Next Generation. I mean, you got a lot of good actors there. So, who is John Cusack? Never heard of him before. All right, that's our little bit of fun today. Let me go back to the handy dandy. Let me shut off the recording, and we got to talk, so don't leave yet.